So let's continue what we did with the last video. So we've showed that the work to go from 1 to 2 due to the electric force is Q times the difference in potential between point 1 and point 2. And we defined this Q times V1 minus V2 to be U initial minus U final, and we identified this U to be potential energy. So this difference is the difference in potential energy between two configurations in space. So the initial configuration, U initial, is in this situation when the charge is located at position 1. Then the energy of the system is called U initial. When the charge is located at position 2, then the energy of the system is called U final. And it's important to know what V1 minus V2 means. V1 minus V2 is the potential difference between 2 points in space, this point and this point. So we've showed that the difference in energy between the two different configurations is the charge times the potential difference between the 2 points. And what is this potential difference equal to for a constant electric field? We've done this problem many times before. When you have a constant electric field, how do you get the potential difference between points 1 and 2? We know it's just electric field times the distance between the 2 points. And in this case, we can write the distance as y1 minus y2, because y1 minus y2 will give you a positive number, and we know that v1 minus v2 is positive. So we can write then the difference in potential as E times y1 minus y2. We can expand, push the Q and E inside, and then we can write it as QEY1 minus QEY2. So we can then identify that the initial potential energy of the charge field system, the system consisting of the charge and the electric field, U initial, is QEY1. And you can compare this with the case we had for gravity. Remember, for gravity, when you had a mass above the Earth, the potential energy was mgy. So the mass takes the same role as Q, and the gravitational field takes the same role as the electric field, and the height is the same in both cases. So we can say that when the charge is located at this high position, or in this particular position relative to the electric field direction, then the potential energy of the system is high, a large value, and it's equal to QE times Y1. And when the charge exists at this lower position, or this lower position relative to the direction of the electric field, and then we can say that the energy of the system is equal to QEY2. So this gives us then a relationship between the difference in energy between two different configurations. U initial is the potential energy of the system when the charge is at position 1. U final is the potential energy of the system when the charge is at position 2, and how this difference in potential energy between two different configurations is related to the potential difference between 2 points in space through the charge. And we know from before that the potential difference is related to the work due to the electric force to go from 1 to 2 in this way. And so now we have a very nice relationship between the work, the potential difference, and the difference in potential energy between two different configurations. And because these two things, U initial minus U final and V minus V, they have the same name, we have potential difference in potential difference, and difference in potential energy, or potential energy difference between two different configurations, there's some confusion usually between these two. So in the next videos, we're going to try to illustrate more what the difference is between these two things. If you want to just multiply by -1, you can also rewrite the equations this way.